Let's have a look at something now called scale factors. Here is a rectangle. We're asked to draw another rectangle where each side is 3 times as big. Let's take the width of the rectangle. The width currently is 1. We want it to be 3 times as big. Well, if we multiply the width by 3, we can see that the new width must be 3 times as long. Let's have a look now at the length of the rectangle. The current length is 3. Let's make this length 3 times the size. So 3 times 3 equals 9. And we can see the new length of the rectangle must be 9. And now we can fill out the rectangle. And we can now fill in this sentence. The shape has been enlarged by a scale factor of 3. It is 3 times the size. Here is an irregular hexagon, a 6-sided shape. We're asked to enlarge the hexagon by a scale factor of 2. So we want to increase each side length by twice as much. Let's take this length. We can see currently it is 3. Well, for a scale factor of 2, it needs to be twice as long. Let's work our way around. Let's look at the next side length. Well, currently it is 2, so to make it twice as long, it needs to be 4. Again, working our way around, the current side length is 2. Let's increase that by a scale factor of 2. The next side is 1. Let's increase that by a scale factor of 2. And again, 1 again. This time, another scale factor of 2. The top length, we can see, is currently 3. So a scale factor of 2 would increase it to 6. We can see our hexagon. And we now know that the shape has been enlarged by a scale factor of 2. It is twice the perimeter. Have a go at questions 1 to 3. Here is a triangle. Enlarge the triangle by a scale factor of 4. Well, currently, one of the sides is 6 centimeters. To enlarge it by a scale factor of 4, I need to increase it by 4 times. Well, 6 times 4 is 24, so the new side length would be 24 centimeters. The bottom side length is currently 5, so let's increase that by a scale factor of 4. And 5 times 4 is 20 centimeters, so the new length is 20 centimeters. And now we can draw the triangle. Rectangle A has been enlarged by a scale factor of 3 to make rectangle B. Find the perimeter of each rectangle. Well, we know parts and details of both of the rectangles. Let's have a look at the length 4. Let's find the corresponding length on side B. This has been enlarged by a scale factor of 3. So to work out this length, we could do 4 times 3 is 12. So this length must be 12. Let's repeat the process, except going this time from rectangle B to rectangle A. The top length, we can see, is 18 centimeters, and the corresponding length on A would be this one. Well, it's been increased by a scale factor of 3, so in order to go from rectangle B to rectangle A, it must be divided by 3. So the length must be 6 centimeters. What about the perimeter? Well, I can calculate the perimeter of A. I can see that it would be 4 add 4, thinking of opposite sides of a rectangle being the same, and 6 add 6. I can see that 4 plus 4 plus 6 plus 6 is 20 centimeters. And for rectangle B, I can see that it would be 12 plus 12 plus 18 plus 18 equals 60 centimeters. So the perimeter of B is 60 centimeters. I can see that the perimeter of A and perimeter of B has also increased by a scale factor of 3. I wonder if this is the same for the area. Now it's your turn. Have a go at the rest of the worksheet.